Alright, so this is the first period video. We'll do 1, 4, 7, 10, and so on. And then the other videos will have the other problems. And of course, everything will be neatly labeled in Schoology so you can find what you're looking for, I hope. Alright, use a calculator only when we're indicated. So on this worksheet, it kind of jumps back and forth between calculator and no calculator because, hey, it's just practice and no one cares if you use the calculator in the wrong spot. Obviously, tomorrow, the tests are separated into pieces so that we can sort of enforce the calculator, no calculator rules. Number 1, the speed of a runner in miles per hour on a straight trail is modeled by. Okay, and this is the speed, so let's be careful about what we know here. Where m is the runner's distance in miles from the start of the trail. What is the maximum speed of the runner for between 0 and 3? So I want to maximize f. F is the speed. I want to maximize that. Well, I don't know what f looks like. Well, I guess I kind of know what it looks like. It's a cube, and it's a negative cube. So it looks something like that. The maximum speed would be where the slope is 0. I do need to be careful with these endpoints. I might need to check the endpoints. So I need to worry about 0 and 3. And then I need to worry about a midpoint, or not a midpoint, but a critical point in there somewhere. Okay, so in fact, I think I'm going to set up my table, m and f of m. So I know 0 and 3 will be on the table. Those are my endpoints. Possibly 2 other points, but no more than 2 other points, because this is a cubic, and I know what a cubic looks like. So f of m, I think I'm going to distribute the 1/10 before I take the derivative. So negative 1/5 m cubed plus 9/10 m squared minus 6/5 m plus 7. So we take a derivative because we want to find where those horizontal tangent lines are, where those critical points are, where the possible maximums and minimums are. So negative 3/5 m squared plus 18/10 or 9/5 m minus 6/5, and then the 7 goes away. I don't know if that factors or not. I hope it does because I don't have a calculator on this. I'm going to take out a negative 1/5, 3m squared. Whoops, I should have taken out more than that. Minus 9m plus 6, which means I could have taken out a 3 as well. So negative 3/5 m squared minus 3m plus 2. Alright, so m minus 2 and m minus 1. So m equals 2 and m equals 1. They did a nice job of putting both of those in between 0 and 3. So I have to check 4 different things to see which one is the maximum. Alright, if I plug in 0, that's the easiest one. I get 7 for an answer, right? Because all that stuff goes away. And I'm looking for the maximum. So look at my answer choices. It's at least 7, so I know it's not one of those 2. So now I'm just curious if somebody gets to 7.5. Alright, let's plug in 1. 1/10 of negative 2 plus 9 minus 12 plus 7. So that would be negative 14 plus 9 is negative 5. Negative 5/10 plus 7. That would be 6.5, which is definitely not the maximum, but I see where that answer came from. If I plug in 2, I'm running out of room here. 1/10. Negative 2 times 2 cubed is 8, so that's negative 16. Plus 9 times 4 is 36. Minus 24. Plus 7. Where were we? Plugging in 2, so that would be 20. Minus 4 is negative 4. Negative 4/10 plus 7. That's where we get the 6.6 from. So that was 2. And then I check 3. Wonder if it's going to be 7.5. Who knows? 1/10. 3 cubed is 27. Times 2 is 54. Plus 9 times 9 is 81. Minus 12 times 3 is 36. Let's see. 54 and 36 make 90. So negative 90 plus 81 is negative 9. Negative 9/10 plus 7. No, that's so is 6.1. So it was 7. It was the endpoint. Main point of that one was don't forget to check the endpoint. I suspect quite a few people would have only checked the critical points, and they would have picked the bigger critical point, which is 6.6, but that's still not the right answer. So that's kind of frustrating, maybe a pain, because you have to do all this work, and in the end, it was just the simplest possible answer at 0. But you don't know that until you check everything. So looking for maximums and minimums, make sure you check the endpoints. Obviously, if there aren't endpoints, then you don't have to worry about the endpoints. All right, number 4. Particle moves along the x-axis so that at time t greater than 0, its position is given by this thing. At what time is the particle at rest? Okay, calculus talk for velocity equals 0. This is the position, though, and velocity is the derivative of position. So 6t squared minus 42t plus 72. That was nice of them to make it so that the 6 will factor out. T squared minus 7t plus 12. Yeah. So t minus 3 and t minus 4. So at t equals 3 and t equals 4. Easy one. At some point, I feel like students start to like the no calculator questions better than the with calculator questions, right? Because the numbers work out, and they're usually easier on the math side. Obviously, you don't have the calculator as your security blanket, but you get nice answers, and things work out. Number 7. Well, calculator. So, no promises on how pretty the numbers are on this one, as you can see from the answers. Particle moves along the x-axis so that time greater than 0. The position of the particle is given by what is the velocity of the particle at the first instance the particle is at the origin. Ugh. Okay, well at the origin that would mean x equals 0. So let's plug in. Oh, that's yesterday's problem. Let's plug in 0.5 t to the 4th minus 1.5 x cubed minus 2x squared plus 6x minus 1. Always take the extra 2 seconds to make sure that it's typed in there correctly. Right? The calculator doesn't make mistakes, so make sure you don't make a mistake. Window, I know I can start at 0. I don't know how far to go, and I have no idea about my y values, so I'm just going to go negative 5 to 5 and we'll see what happens. Whoops, that's off the screen, but I think it's fine that it's off the screen because what I'm looking for is the first time it's at the origin. The first time that x is 0 is way over there. In fact, I may change my window to not go all the way to 10. I may just go to 4 here. Oops, I think I started at 4. Window, yep, let's go 0 to 4. Here we go. Okay, so at the end it goes crazy off the screen, but I don't care about that. First time it crosses, first time it's at the origin, the first time x is 0 is right there. So I need second calc 0. So I can use the calc 0 button. Left bound, right bound, guess. So x equals 0 at t equals 0.1786 ... Since I'm going to need that number, I'm going to save that. I'm going to store that as a. You don't have to do that. You could write down the decimals. And since our answer choices are all far enough apart, you're probably not worried about accuracy.
How do you store it?
Okay. So after you find it, the question was how do you store it? After you find it, second calc 0, left bound, right bound, guess. So right now it's like the last thing in your calculator's brain is the 0.1786 ... So quit out of there. And that's still the last thing in its brain. Then you hit the store button, STO, bottom left, and then pick whatever letter you like. And it'll sort of confirm it to you that, hey, we're still talking about the 0.1786, blah, blah, blah. And now anytime you need that time, you can just use A and you don't have to type in all the decimals. What is the velocity? Okay, well the velocity is dx dt at t equals, and you can even use that in the, this is multiple choice, so it doesn't matter, but in a free response question, you can use A if you'll tell the grader, me, what A is. So if you say A is equal to that, then you don't have to write that anymore. You can just start using A. Okay, so back to my graph. Okay, there's several ways I could do this. I could take a derivative by hand and plug in A, but I've got a calculator, so I really don't want to do that. Let's let the calculator find the derivative at A. And so my slope is 5.153, which should be the velocity. And there's that answer, 5.513. Remember the other way is to do it out here, math 8. Let's see, I think that was in for y1 at x equals. And again, you could type in the time, or if you've got it saved as A, 5.153. I feel like you guys are there's plenty of people who do it this way, and there's plenty of people who do it on the graph, take a derivative. Either way is fine. Number 10, another calculator. The velocity of the particle. Okay, so now, again, that's velocity. Which of the following statements describe the motion of the particle at t equals 1? Okay, moving left, moving right, versus positive or negative acceleration. So I need the sine of v, and I need the sine of a, which is the same thing as dv dt. So, square root of x minus cosine of e to the x. What a goofy thing going on there. At t equals 1, so as long as my x window includes 1, I'll be fine. I have no idea if my y's are correct or not. We'll just see what happens. And we're good. This there's x equals 1. I don't know what happens after that, but don't really care. Okay, clearly v is positive because it's above the x-axis. I mean, I guess if you really want to know what it is, the value is 1.91, but all I care about is it positive? What about the slope? Can you tell by looking? I don't even need to do a derivative here. I mean, like, find the value. What's the slope of that line, positive or negative? It's positive. Now, if you want to find the derivative, you can, but it's really not necessary. You should be able to tell by looking. 1.617. Okay, so velocity is positive, acceleration is positive. So velocity positive means we're moving to the right with derivatives positive, positive acceleration.
How did you get positive velocity?
I knew the velocity was positive because this picture is the velocity,
Okay.
and it's above the x-axis, so it's positive. I mean, if you want to get the details of it, you can actually find that it's 1.91, and that's positive. But really, I didn't need either of these numbers. I can tell by looking that v is positive and the slope is positive. And lastly, for this video, number 13, a particle moves along a straight line. The graph of the particle's velocity is shown at the right. A bunch of letters on there. The graph intersects the horizontal axis at K and M and 0. Horizontal tangents at J and L. For what values of t is the speed decreasing? So that means V and A have opposite signs. And A is the slope of velocity. So I need the sign of velocity and the slope of velocity to be different if the speed is decreasing. So what about 0 to J? Velocity is positive. What's acceleration? Positive, because the slope is positive. So that's speeding up. That doesn't count. What about J to K? What's the velocity? And what's the acceleration? How do you know the acceleration is negative? Because the slope of the velocity is negative. So J to K is definitely one of the spots. K to L, velocity is negative and acceleration is negative, so that's speeding up. And then L to M, velocity is negative, but acceleration is positive, so L to M. So J to K and L to M. I wrote it in interval notation. The answer over here is in inequality notation. J to K, L to M. It's funny, all the calculus teachers are like kind of at the same spot in their curriculum, because someone yesterday on my favorite Facebook group asked, on a free response question, do they want the answer in interval notation or inequality notation? And the main moderator guy was like, either one on a free response question is fine, but do make sure you understand both, because both show up in multiple choice. So you answer however you like. If it's free response, make sure you understand both for multiple choice. I also think there was maybe a different way to answer this. Like the speed is decreasing. So where speed is like headed towards 0. So that's from J to K. This is like a very intuitive understanding of what's going on. From J to K, my velocity is headed towards 0. And from L to M, my velocity is headed towards 0. And so forget slopes and values. That's just a really good understanding of what's happening if you do it that way. Not a very calculus way, but you can still get there. Okay, that's it for that video. Look at the other videos for the other questions.